Hello and welcome to this video in which we are going to take a base 10 number and write it in its IEEE 754 representation. The number I've chosen is negative 12.8125. We first of all have to write this out in base 2. That is to say, we have to write it out as negative 1100 because that's 12. And for the 0.8125, we are going to do what we did before, break out that little table, x, 2x, bit, and the question as to whether or not we should subtract 1 or not. So if we do that, there we go. Sorry, a little bit of a glitch here with my tooling here. Let me go ahead and erase that and go back to green. So I'm going to start off with, let me move this out of the way. I'm going to start off with 0.8125. I'm going to double it, and that's going to get me 1.625. There's a 1 there, get a 1, and should I subtract 1, that's actually the fourth column, and the answer is yes, because it's 1.625. So the next number becomes 0.625. I double that, get 1.25. Again, there's a 1. So I subtract 1. The answer is yes. I get 0.25. I double it and get 0.5. So the next bit is a 0. Should I subtract 1? No. I double it and get, so I have 0.5 here. I double it and get 1.0. So this bit is a 1. Should I subtract 1? Yes, because remember, if it's greater than or equal to 1, I subtract 1. I get to 0. I'm done. So my entire number is 1100.1101. Now, if you want, this is really times 2 to the 0, right? Because that's times 1. In order to normalize this, I need to bring this over 1, 2, 3 to the left. And remember, left means add. So negative 1.1001101 times 2 cubed. So that's the normalized version of negative 12.8125 in base 2. Next, I have to put this into the IEEE 754 format, so it's going to look something like this. So first we've got our sign bit, and that's going to be, it's negative, so that means this is going to be a 1. We then need the exponent. We need 8 positions for that. 1, 2, 3, 4, 5, 6, 7, and 8. Now, just draw it like that. This is going to be 1, 2, 4, 8, 16, 32, 64, and 128. I take this exponent and I add 127 to it. So 3 plus 127 is 130, which means I need a 128 and I need a 2. And everything else is going to be a 0. All right, got that? Next, I fill in the rest with the mantissa. So I ignore the 1 point because that's assumed. So I'm going to take 1, 0, 0, 1, 0, 0, 1, 1, 0, 1. Just this part here. And so it's going to look like this. Not sure why that little line popped up there, just to bother me. Okay. And that is, and of course, I need more zeros. Remember, we have a total of 23 bits here. And in answer to a student's question, you can just write at this point 0, ... like that. That's the answer in base 2. Now, to convert it to base 16, you have to hack this up into groups of 4. And so I'm going to try a different color. This is going to be very exciting. I'm going to use red. If I can get red to work. All right, so now I'm going to break them up in groups of 4, 1, 1, 0. So there'll be 4 here, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, and zeros all the way past. So 1, 1, 0, 0 is, of course, C. 0, 0, 0, 1 is 1. 0, 1, 0, 0 is 4. 1101 is D, and it zeros past that. 0, 0, 0, 0. This is 1 byte, 2 bytes, 3 bytes, 4 bytes. We are done. Nice job. If you have any questions about this video, please let me know. So actually, before I wrap it up, so that's showing you how to go from base 10 to represent the number in IEEE 754 format. The other way to go is basically the reverse. So let us suppose we had this number here, okay? I had C1 4D, so I'm just going to do this in, I know this is sort of lame, I'm just going to do this in reverse order. So I'm going to, suppose I said I've got the number C1 4D 0000. All right, you would write C, you would write 1, you would write 4, you would write D, and then zeros, like that. And so you would just write out. So this is the IEEE 754 format. We're now trying to show what does it look like in base 10. So I take this, and now I'm going to again switch colors. I'm going to go back to green. I sort of like green. And we are going to cleave it off. So here's the sign bit. Then I take the next 8. 1, 2, 3, 4, 5, 6, 7, 8. And I take this number, and this is 128, 64, 32, 16, 8, 4, 2, and 1. So just sort of like that. So this represents the number 130, but I subtract 127 to get the exponent. Remember, we're actually looking for a number -1 to the s times 1 point f times, 1 point f times 2 to the e plus whatever that exponent is, plus 127. Okay, so I'm sorry, subtract 127. So the exponent was 130, so we're going to take 130 minus 127, we'll get 2. The fractional component is from here on down, so it's going to be basically -1 to the 1, because it was 1 there, and it's going to be 1.1001101, and a whole bunch of other zeros, times 2 to the 130 minus 127 times 2 cubed. So we write that out as -1 to the -1 of the first, it's still -1, times, now it's 2 cubed, and so we have to move this 1, 2, 3, so that's 1100.1101. All right, and now we've got, this is the number 12 point, and I've got a half plus a quarter, no eighths, and a 16th. So I've got a half plus a quarter, no eighths, plus a 16th. You can do the arithmetic on your calculator, and that will give you the result. All right, that is the end of this video. I hope you watched this. I hope you had as much fun watching this video as I had making it. For the record, this is about the 18th time I tried to record this. I kept having glitches with my pencil. I bet I'm going to stop this at this point, and the audio won't have worked, and you will hear the screams from here. Anyway, if you have any questions about this, please let me know. I'll have office hours tomorrow at 2. See you then.